All right, so in today's video, we're going to learn how to determine whether a function is even, odd, or neither. So the definition of an even function is a function such that f of negative x equals f of x. An odd function is a function such that f of negative x equals negative f of x. And if a function is neither odd or even, then f of negative x does not equal f of x, and f of negative x does not equal negative f of x. So basically, if it's neither, then these two conditions are not followed. So what this basically means is that for an even function, if you plug in negative x into the function wherever there's an x, you should get the same function back out. And for odd functions, if you plug in negative x, you should get the negative version of the function after you simplify everything. So let's go ahead and look at some examples. So the first example is I want you to try to determine whether the function x to the fourth plus x squared is even, odd, or neither. So go ahead and try that out and come back when you're ready to see the solution. All right, so the first thing we're going to do is we're going to substitute in a negative x wherever we see an x and see what function comes out. So if we're going to write this as negative x to the fourth plus negative x squared. And simplifying this, we're going to get negative x times negative x times negative x times negative x. This is all negative x to the fourth. And we're going to add that to negative x times negative x. And this is negative x squared. So now if we go ahead and simplify this, we know that two negatives will make a positive. So these two negative x's are just going to come out to be positive x squared. And the same thing with these two are going to be positive x squareds. So what we're going to have is x squared times x squared. And then these two negative x's together multiplied will also result in x squared. And then we're going to add x squared. So multiplying the two x squareds together, we're just going to have x to the fourth plus x squared. And if you notice, this resulting function is the same thing as what we started off with. So our conclusion from that is that f of negative x, so when we plug in this negative x's, is going to result in the same function. And if we look at our rules, we notice that that is the property held by even functions. So even functions have that property. So we can declare that x to the fourth plus x squared is even. All right, now let's look at another example. So our second example, so example 2, is going to be the function the absolute value of x. So we're going to go through the same process. We're just going to plug in a negative x whenever we see a x. So what we're going to have is the absolute value of negative x. And if you know how to work with the absolute value function, you know that the absolute value is just going to negate that negative because the absolute value is telling you the distance that that number is from 0, and that doesn't change whether you're on the negative side of the number line or the positive side of the number line. So what you're going to end up having is just the absolute value of x. So we can see again that f of x, this guy, is equal to f of negative x, which is this guy. So the absolute value of x is even. All right, let's look at a third example. So example 3 is going to be the function x cubed plus x. Again, we're going to go through the same process. Wherever we see an x, we're going to plug in a negative x. So we're going to have negative x cubed plus negative x. So this is going to be equal to negative x times negative x times negative x. This is all negative x cubed plus negative x. Simplifying this, we know that two negatives will make a positive. So these two negative x's are just going to come out to be x squared. And then we're going to have a leftover negative x. So what we're going to end up with is negative x cubed. And then we still have this negative x. So this is actually going to be adding a negative is the same thing as subtracting. So we're just going to have a minus x. So now what we end up with is something different than our original. So our original was x cubed plus x, and our final was negative x cubed minus x. But one thing you can notice is if we factor out a negative 1 from our final answer, we'll have negative x cubed plus x. And this inside function is the same as this function. So if we replace this with f of x, and this is also f of x, then we've just shown that f of negative x equals negative f of x, because when we plugged in a negative x into our function, like how we did here, we ended up with the negative version of the whole function. So if we go back to our rules, this is the property of an odd function. So that's this property right here. So we just shown that the function x cubed plus x is odd. Now on to our next example. So our next example is x squared over x cubed minus x. So again, we're going to go through the same thing. We're going to plug in a negative x wherever we see an x. So we're going to have negative x squared all over negative x cubed minus negative x. And then simplifying this out, negative x squared is just going to be negative x times negative x, which is going to be x squared. And our denominator, negative x cubed, is going to turn out to be negative x cubed, like this. And then subtracting a negative is the same thing as adding. So this is plus x. So now, if we observe our functions, we notice that they obviously don't match up. So this does not equal to this. So let's see if the negative version of our original function will end up resulting in what we came up with. So if we multiply our original function by negative, we're going to get negative x squared over x cubed minus x. And we can see again that this is not ending up matching up unless we factor out a negative 1 from the top and bottom. So if we factor out a negative 1 from the top, we're going to have negative x squared still. And if we factor out a negative 1 from the bottom, we're going to have negative x cubed plus x. Because if you distributed this negative, you would come back to this expression right here. So now what we can do is we can actually cancel out the negatives from the top and the bottom, because that's the same thing as multiplying by negative 1. And so we're going to have x squared over negative x cubed plus x. And if you notice, that's actually the same as what we had over here. So this function, x squared over x cubed minus x, is odd, because f of negative x equals negative f of x. So basically the process you want to go through is substituting in a negative x into the function, and then once you find out what your resulting function is, if it matches up, that's great. You've already figured out that it's even. But if it doesn't match up, try to multiply the original function by negative 1 and see if you can manipulate that to look like what you ended up with. If you can, then your function's odd. If you can't, then it's neither. So now that we've seen how to manipulate these functions algebraically to see if they're odd or even or neither, we can also observe their symmetry graphically. So if we go onto our graphing calculator here, we can actually plug in our functions. So our original first example was x to the fourth plus x squared. So if we plug in x to the fourth plus x squared into our calculator, we can see that the graph is neatly symmetrical about both sides. This side right here is the same as this side right here. And that indicates to us that this is an even function. So other functions that look like this include x squared. Again, you can see x squared is the same on both sides of the y-axis. And also the absolute value of x, which was another example that we had right here. So any function that looks the same on both the x and y sides, or sorry, the positive x and negative x sides of the graph is going to be an even function. Now let's look at some other examples that we did. So another example we did was x cubed plus x, and we proved that this is odd. So if we go ahead and graph this, you can notice that even though it's not symmetrical about the y-axis like the even functions were, it still looks kind of the same. It looks like if you were to flip this area of the graph, so all the side that's to the negative side of the x-axis, and you flipped it up over the x-axis, you would actually have what looks like an even function. So this is the property of odd functions. Odd functions look like they're reflected over quadrant 1 to quadrant 3 or quadrant 2 to quadrant 4. They sort of cross over the origin and are symmetric about the origin in that way. Other functions like this, x cubed, you can see that x cubed also has sort of the same idea, and negative x cubed. Negative x cubed, even though it's not the same quadrants, it still is symmetric about the origin, just in the opposite way. And we can also verify that our final example was odd. So this example was x squared over x cubed minus x. So we have, oh, whoops, x squared over x cubed minus x. And you can see that again, it's symmetrical about this origin. All right, so that's how we determine whether a function is odd, even, or neither. And we're done.